The first part, the theory section, we're going to start with just number one, memory versus storage. Okay, so inside of our computer, we know we have different components. So this is going to be our hardware side. Hardware, remember everything we can see and touch. Okay, so memory and storage is one of those hardware components. The main differences between memory and storage is that our memory is going to be temporary versus our storage is going to be a form of permanent. So temporary means it's only for a certain amount of time, whereas permanent is you can store it for a longer base time. So you can store it forever if you actually want to. Okay, so with memory, the hardware components that we normally talk about is going to be our RAM. Can you remember what RAM is? What is RAM used for?
Yes, so it's RAM access memory that's used for like, so memory that can only be stored forever or something.
Yeah, okay.
So it's
There we go. Okay, great stuff. Nice. Okay, both of you perfect. So RAM is random access memory. And what RAM's purpose is it basically stores the instructions the computer is currently working with. So if you go and you open up Microsoft Word, it will take all of the Word instructions, it will load it into RAM, so that when the CPU wants to basically run a set of instructions, it will get it straight from RAM and it will execute. So what the purpose is, it will basically speed up the computer. Remember, our storage is our slowest form inside of the computer. It's very slow. Then faster than the storage will be our memory, our RAM. And then even faster than memory, the fastest component is our CPU. So what it will help, it actually helps speed up the computer, because what it's going to do, like I said, it temporarily stores the information the computer is currently working with. So it doesn't have to go all the way to storage, which is very slow, to get data and instructions from. It can just go to the memory. Okay, so that is the biggest part. And then you say the characteristic is it's volatile. So volatile, great stuff. When the computer loses power, it loses all of its data inside of the memory. So RAM basically gets wiped clean every time the computer switches off. 100%. Okay, another just characteristics you can say about memory. It is faster than storage. Okay, and then the last one, a lot of people like to say it's expensive. Okay, that's the first thing that pops into your head. If you think of memory and storage, you say, ah, memory is so much more expensive. Just be careful when you're saying it's more expensive, just say it is more expensive per gigabyte. Okay, reason being is you can get a hard drive, 500 gigs, for about 500 Rand. So it's almost like a Rand a gigabyte. But with RAM, it's going to cost you like 500 Rand for a 4 gigabyte. So there's a massive gap, and then the whole difference is just because one is completely electronic, one is a hard disk drive. So it is more expensive, but per gigabyte. Okay, just keep that in mind. Okay, storage. We get two types of storage that we mostly focus on. There's a lot of others, but if we talk about storage, a permanent storage, the two that we focus on is going to be our HDD or our hard disk drive, and our SSD, which is our solid state drive. Okay, so hard disk drive is basically a mechanical form of storage. Oh, hectic. The wind just blew a few things over here. Okay, so hard disk drive is a mechanical form of storage. So we have this hard drive. Inside of it, there's a spinning metal platter that basically spins the whole time. Then we have that magnetic read write head that goes across that spinning metal platter, and it reads the ones and zeros and it reads the data off. Okay, so that is the first part. Hard disk drive, you just have to know it's mechanical, and the other one is an SSD. The SSD stands for What does it stand for? SSD?
Solid state drive.
Okay, and what is the difference between a HDD and an SSD? Okay, so our SSD is completely electronic. Okay, there's no moving parts inside of our hard drive, so it actually uses capacitors to store information. Okay, so hard disk drive, mechanical, uses moving parts. SSD is electronic. So which one is much faster? It's going to be our SSD. Okay, so because the hard disk drive has moving parts, it's much slower, SSD very fast. Okay, so that is the two main differences between the two. One is mechanical, one is electronic, one is slower, one is faster. And again, if you want to go and say cost again, try to avoid the cost one. But if you want to go cost, our SSD is going to be more expensive per gigabyte. Okay, so again, just to give you a simple example, hard disk drive 500 Rand for 500 gigs, whereas an SSD you're going to pay 500 Rand for 240 gigs. So it's like almost double the price for the SSD because it's just so much faster.
So what are examples of SSDs?
So it's actually a complete hard drive, so I can actually quickly show you. Um, Let me quickly show you. If we go into Takealot, I can give an example. Hey, is it my internet that's so slow? Yo. Okay, there we go. Okay, so let me show you just an SSD. Okay, maybe just Google it as well. SSD. Okay, hectic. I don't know if it's my laptop or the internet, but something is terribly slow. Okay, so it's basically just like this. It's a normal hard drive. If you open it up, you'll see basically just circuitry. There's That's it. There's just circuitry going on. So if I can maybe just SSD internals, maybe that will give you just a better understanding of how it looks. So it looks like this. So it's just an electronic circuit board. It uses capacitors and resistors and stuff to store. Oh, here's a very nice example. Hectic. Okay, let me open this up nicely. Open image in new tab. This should be good. Okay, so the differences is this one on the left is our hard disk drive. One on the right is our SSD. So over here it shows you that the SSD is just circuitry if you open it up. There's no moving parts, it's just as is. Where our hard disk drive has this metal platter on the inside and it works on a motor. So what is going to happen is this platter is going to spin around almost like a wheel. It's going to basically spin that platter at high speeds. It's like 5,300 RPM. Now RPM stands for revolutions per minute. Okay, so that means in 1 minute, this disk will spin 5,000 times. Okay, then we have this what we call it's the read write head. This thing here on the middle side, and what it does is it moves on this spinning platter. It goes up and down, up and down, up and down, and every time the disk spins around, it will like read a bit of information, and then when it gets back to its original position, it will read a bit more information, etc. So obviously, if you think about it, if you want to open Word, this spinning metal platter is gonna spin 5,000 times a minute, and it's gonna basically every like millisecond or 2 milliseconds it will read like 1 megabyte of Word. Then once it gets back to the files where Word is located, because Word will be somewhere like on the disk itself, and then the rest of the disk there's other stuff included, so it basically just takes longer to load. Whereas our SSD, it's completely electronic. So if you want Word, it will go locate where Word is and it will open it up one shot. It's much faster. Okay.
So
do you connect your device to like an SSD?
So inside of your computer, you basically just plug it in. Let me quickly show you. Uh, okay, let me quickly just get a nice image here. Okay, where can I? Which one is nice? Okay, so this one is kind of a nice image. I'll quickly open it up for us. Which one? No, that's too small. Sorry, let me just quickly grab a nice one so that we can see much better. Okay, this one should work. Oh no, that's a YouTube video. Okay. Oh, come on, why is it so small? Okay, let me try to. If I can zoom in, it will be actually good. Oh no, this looks terrible. Okay, I don't know why they chose to make the images so freaking small. Okay, maybe I can. It's the last hope. Ah, hectic, it's so small. Is this clear or not really? No, it's not clear. Okay, just give me 2 seconds. Let me find one. It's a good question. I'm gonna be honest. Open new tab. Let's hopefully this one is better. Ah, okay, so this one is a bit better. Okay, so what is inside of our computer is over here we've got our motherboard. Okay, the functions of the motherboard is gonna be number one. It connects all of our hardware devices to each other. Okay, so on a motherboard, you're going to plug in your CPU, you're going to plug in your RAM, you're going to plug in your storage. Everything goes onto your motherboard. Even if you want to insert a USB drive, CD drive, everything will go to your motherboard. So number one, a motherboard connects all the hardware components. Okay? Number two, what the motherboard does is your power supply over here. You basically plug in your 220 volts, so that is like your wall socket. It goes into the power supply, and the power supply will basically bring it down to the required voltage, normally like 12 volt or whatever. And it basically goes from the power supply, it plugs into your motherboard. Okay, so first one that the motherboard does, it connects all the hardware components inside of the computer. Number two is it distributes power to all the components. So your power supply will give power to your motherboard, and your motherboard will say, okay, I need to give power to the CPU, I need to give some to RAM, I need to give some to the hard drive, etc. So that is the second thing a motherboard does, it supplies power. Number three is it basically is just a physical structure for everything to connect to. Okay? Number four is what the motherboard also does is it has connections on the motherboard. So there's like wires connecting all of the components to each other. So it will allow communication between all the components. Okay, so just remember that. Number one is it supplies a physical structure for all the devices or hardware components to connect. Number two is it supplies power to all of the components connected. Number three, it allows for communication. And number four, it just connects all the devices. Okay,
Yes, sir. Thank you.
so that is the motherboard. Sorry, then what we will have here is our hard drives will basically, so that image I showed you will just be inside of the computer case. It will just be there, and then it's going to go with a wire, it will connect to the motherboard. Normally via SATA, or the old connector is an IDE, but we don't speak about IDE anymore, so it's just a SATA connection. So it just plugs in on the motherboard, and that's how you connect the SSD to your motherboard. So you can either use a hard disk drive or an SSD inside of your computer. Okay, so all of your devices basically just connect to your motherboard. That's how the connection takes place. So on here you'll also see that like this computer, the processor or the CPU is also going to be plugged into the motherboard. What is also there is the RAM is supposed to be here, so these slots are empty, but the RAM will plug into the DIMM slots again on the motherboard. So everything is revolving around the motherboard. The motherboard is basically where all the magic happens. Okay, I hope that makes sense.
It does, thank you.
Okay, perfect. Alright, so that is memory and storage. Perfect. The next one, modular design. Okay, so, well, that image is actually going to help me quite a lot to explain the next one. Do you know what modular design means?
No. So,
Okay, cool. So, what modular design means is a device is made up of independent different parts. Okay, so what is meant with that is if we take a look at this image again, you will see that you have your motherboard, and on the motherboard you can plug in a processor or the CPU, you can plug in the RAM, the graphics cards, the hard drive, the everything gets plugged in. So let's say our RAM decides, you know what, it has reached its end of life and it packs up, it breaks. So instead of having to throw away your whole computer, you can just go to the shop, buy another stick of RAM, replace the one you have, and then your computer will be running again. Okay, if your CPU is, let's say it's a bit too old, it's outdated and you feel like, is you not getting the processing you want? Instead of again having to go buy a new computer, you can just buy a better processor and swap the one you have. So what it allows is, number one, a modular computer allows you to upgrade and to fix your computer much easier, sorry, and much more cost effective. So again, it's made up of different parts that is interchangeable. So you can remove it and upgrade it, or you can, if it breaks, you can remove it and put in a new one. Whereas if we think of something that is not modular, is something like a laptop will not be very modular. And what is meant with that is if you take a look at the laptop's internals, you'll see that this is basically how it looks on the inside of the laptop. Now, you can remove the RAM, you can remove the hard drive, but the CPU will normally be like very integrated. It's like soldered onto your motherboard. So if the CPU decides to pack up, you need to buy a whole new motherboard. And that is almost the price of a new laptop. Okay, so it's not very easy to fix. And another great example of something that is not modular is if you think of a phone's internals. Okay, so let me quickly just show you how a phone looks like. I hope this is gonna open up quite nicely. It's just opening with a new tab. No, that sucks. I'm having so much bad luck over here. Okay, I think this one. Okay, can you see on this side? I think this isn't too bad. Okay, so in a phone, it's basically the same thing. So you have everything is basically soldered onto your motherboard. So if your storage packs up, you can't just go ahead and quickly, you as a normal person, go buy another chip of storage and just quickly plug in and or plug out, plug in. You normally need like very high tech special equipment to desolder everything, and that means it's not just okay, this thing broke, let me just remove it, plug in another one, and it works. So that is what is meant with non-modular. Okay, so computer very modular in the sense that again, if something is to break, you just go to the shop, you remove the one that's broken, you plug in another one, it's up and running again. You don't even need to have expertise. So if you want to just recap modular design, it is a device that is made up of independent different components that is easily interchangeable. Okay, great stuff.
Yes, sir.
So the motherboard I kind of already covered. So again, motherboard allows connecting all of the devices, allows communication between the hardware devices that gets plugged into the motherboard, supplies a physical structure for everything to connect to, supplies power. That is our motherboard. Okay, so on our motherboard, we have what is called a bus and a point-to-point connection. Okay, so if I just quickly show you an image of our motherboard. Let me quickly just, yeah, this is quite a nice picture. I just hope it's not going to be small again. Okay, so on the backside of our motherboard, we have this, it almost looks like integrated wires that is like inside of the motherboard on the circuitry. Okay, all these small wires, what it does is it basically goes to from one component, so it will connect all of our components together. So if something needs to travel from the storage to the RAM, it's going to follow these communication lines basically. And then from our storage, if it needs to go to the CPU, again it will use these lines. Okay, so these lines is these two types we get. The first one is what we call a bus connection. So what a bus connection is, it's basically if you think of a bus, what does a bus do? It goes from one location. If it needs to, let's say I need to travel from Richards Bay to Cape Town. Okay, what is a bus going to do? It's going to drive from Richards Bay. It's maybe going to make a stop at Durban. Then it's going to drive on, get to maybe Pietermaritzburg, and then it will stop again. It will load in some passengers, load a few passengers out. You get the point. So it's going to basically drive from town to town and then drop off some people, pick up some people, etc. That is what a bus does. It's not just going from one place to another place, like almost like an airplane. So on the motherboard, we get these connections that are called the bus connections. So what the bus connections are, it is that wires on the motherboard that is basically linking multiple different components together. So that connection will basically go from, let's say, the CPU through to the RAM, to the storage. That connection will also maybe go to your CD drive. So that means just it's a connection that connects multiple different components together so that they can communicate to each other. Okay, it's almost like a group chat. All the devices, so everything on the motherboard basically gets connected together. Okay, do you understand the analogy? Bus. There's multiple drop-off locations. Okay, whereas with a point-to-point connection, that is like I almost said, it's like a plane. So if you want to go from Richards Bay to Cape Town, you're going to get on the plane there at the airport. It's going to go straight from Richards Bay, fly to Cape Town, one shot. It didn't stop anywhere else. It's one connection. So normally our point-to-point connection is, if you take a look at our motherboard again, it's going to be between our CPU and our RAM. Okay, a point-to-point connection is going to be between only two components. Okay, that's important. Bus connects multiple components. A point-to-point connection only connects two components together. So if we take a look at just a more modern motherboard, let's just hope this thing is not small again. Okay, if we take a look on the motherboard, so there is where the CPU is going to be plugged in. And then these long ones, this is called our DIMM slots, D-I-M-M. It's stands for dual inline memory modules. That's not important for now, but that is where our RAM gets slotted in. So just to go back to the bus will basically maybe go from our CPU that gets slotted in here to the RAM, and then that connection also goes to the CPU, that connection goes to our hard drives, it connects the USB ports together, so it connects multiple different components, the bus, whereas the point-to-point only connects two components together. So it will be between like the CPU and the RAM. So that's no other stops. It's a direct connection between two components. So what do you think, what is the point of this point to point? It will just basically increase the amount of information that gets sent between these two devices. So if you just think of the bus is going to drive, stop, load off some people, load on some people, drive, stop, load off some people, load on some people, until it gets to its destination. Whereas the plane flies direct from here to there, no stops in between, so it's much faster. And that is just the difference between the two. Bus connects multiple components, it's a bit slower, whereas the point-to-point is only between two devices, and it is much faster. Are you with me?
Yes, sir.
Okay, great stuff. So the hard disk drive, the SSD, we basically covered. I'm going to get to number 4 at the end. Okay, so our computer is, we know it's consisting of two main components. We talk about the first one was hardware. All of the physical components we physically see and touch. The second one is software. Now, we get two main types of software. Do you know the two main types of software? Ish?
Yes, sir.
Yes.
System and application.
Perfect. System software and application software. So our system software is basically the instructions that controls the computer. It's a set of instructions, programming that controls the whole computer. Whereas our application software is all the programs we install onto our system software that gives us additional functionality. So just to give you an example of the both of those, if you talk about system software, it's basically like the application or the program that controls your whole computer. So I've got a Windows PC. So on my computer, I've got Windows 10. So if I boot up my computer, you'll see Windows 10 gets booted up, I enter the password, and then everything I do is based on Windows 10. But now, this application I have in front of me is Microsoft Word. So when I installed my Windows, I had no typing application. I didn't have Microsoft Word, I didn't have PowerPoint, I didn't even have Google Chrome. So that it was an additional application that I had to install onto my main operating system in order for me to browse the internet, in order for me to type these stuff out, etc., make PowerPoints and so forth. Okay, so system software is the main set of instructions that controls the computer, like Windows 10 for a Windows PC. It can be if you are using Mac, so Apple devices, it's going to be Mac OS. If you have a phone, if you have an iPhone, you will use iOS. If you have an Android phone, the operating system or the system software will be Android. Okay, and then stuff that you install onto that platform, like on your phone, WhatsApp is an application software, Facebook that you install is an application software. All of those stuff that gives you additional functionality is application software. Okay, so just to get back to our system software. Now there's a lot of types of system software. We get like firewalls, antiviruses, all the utilities, programs. I'm not going to dive into it too much, but one of them is this, what I said, the operating system. So that was like Windows, etc. It's just, it controls your computer. So the operating system has a few different key points that it supplies us with. Okay, I want you just to learn these few key points. The first one, what our operating system will do. If you think of the internals in the computer, we have our storage, we have our memory, we have our processing, okay? We have our input and output devices, and then I'm gonna add another one is a GUI. You know what a GUI is? Okay, so a GUI, GUI, it stands for a graphical user
Oh, that's
interface. Okay. Oh, sorry. So GUI, if you say it, we say it, it's a GUI. Okay. So
yes, sir.
just a recap. So when you are speaking about an operating system, I want you to state the following. It manages, what is my slowest component? Storage. It manages what's faster than storage? It's my memory. It manages what's even faster than memory is our CPU, so our processing. It manages our input and output devices. And lastly, it supplies us with a GUI. So I'm just going to repeat that. Manages storage. It manages memory. It manages processing. It manages input and output. And lastly, it supplies us with a GUI. So all the nice stuff we can visually see, the buttons and all that stuff, it supplies us with that. Okay, so start at the slowest component. It manages storage, manages memory, manages processing, manages input output, supplies us with a GUI. That's it. That's all you need to know. That's operating systems covered. Okay, are you with
So,
me?
sir, just those 4 points.
5 points.
Sorry.
Yeah, manages storage, manages memory, manages processing, manages input output, supplies us with a GUI. That's it. That's all you need to know about an operating system. So the next one, the BIOS. The BIOS stands for Basic Input Output System. Okay, so this operating system, before it actually takes control, we have the BIOS. So as soon as you start up your computer, you'll see that there's like, it's like a black screen with white text or normally blue text that appears. It does a few funny things and then it starts loading into your Windows or whatever your device uses. Okay, so that is the BIOS. So as soon as you turn on your computer, the BIOS actually runs. So before it gets to our operating system, our BIOS runs. Now I say it's a basic input output system. So what BIOS is it is called firmware. So BIOS is just a piece of firmware. Now that again is a part of system software. But what this firmware does, or this BIOS does, is it basically is the lowest level of like system software we get. So that's why I say, if you compare it, this is the BIOS. It's just like text based. There's nothing fancy going on. It's straightforward. So it's very low level. Okay, so what this BIOS will do, the BIOS is in charge of our post test. Have you ever heard of the post test?
No, sir.
Not. Okay,
No, sir.
the post test. POST. So what it stands for is the power on self test. Okay, the power on self test. So what the BIOS will do, like I said, it's the lowest level of system software. So when you boot up the computer, you can go into the BIOS and you can actually make changes. So you can basically select which hard drive the operating system must boot on. You can do all this like small things. You can go change system settings like your CPU speed, etc. But the one important key, what the BIOS does, is it will run this sort of a test once you turn on the computer, and that is this post test, power on self test. And it's kind of like self-explanatory in the words. So when you power on your device, it will do a self test just to check if all the hardware components is actually in the computer. So when you turn on the computer, it's going to ask, is the CPU here? Yes or no? Okay, the CPU is here. Is my memory here? Ah, yes, I've got memory. Okay, is my storage here? Yes, we've got our storage. Okay, great stuff. We have all the components we need. So that is the first thing our post test does, is it will check is all the components there that needs to be there. So it's basically taking a register, seeing that no important component is absent. Okay, once it knows that all of the... Yes. Sorry, did someone call? No one? Ish. Okay.
I think it was Navashan, sir.
Oh, is it?
I don't know.
Nafashan? Everything good? Okay. Alright, cool. Okay, cool. So, number one, it checks if all the components is there. So, once it establishes that, listen, okay, I've got all my components, what it will do is it will say, okay, we need to boot up our operating system. We need to boot up this Windows or Android or whatever. So, the first thing it will do after it has checked that all of the devices are there, it's actually going to go ahead and go onto the hard drive and try to locate the operating system. Okay, so number one, checks if all the important components are there. Number two is it will go onto the storage if all of the components are there. It's going to go into the storage and try to locate your operating system. Once it detects the operating system, then point number three, it will load the operating system. And then number four, once the operating system is loaded, number four is the operating system takes over control of your computer. Okay, so the BIOS is just our firmware. It's the lowest level of system software we get. And what it does is the post test, the power on self test. The post test is responsible again, number one, checks if all the components are there that needs to be there. Once it establishes all the components are there, it's gonna look for the operating system on the storage. Once it has found the operating system, it's gonna load the operating system. And then finally, once it loaded the operating system, it gives over control, so the operating system basically takes over. Okay, so what this system will also do is, if it detects that, listen, there is no CPU, it will actually give you like error messages and stuff. So if it detects that, let's say your hard drive got corrupt and it can't detect the operating system, it will actually tell you, listen, no bootable device found. So that is like the main key BIOS. Let's say no bootable. You can actually see there's like errors that the system will give, and it's not fancy. It's literally just text based, like stuff like this. No bootable device found, insert the boot disk, and so forth. So that is what this BIOS does. Okay, so just to come back to this word firmware, just for you to remember what firmware is, it's, like I said, it's very low level operating software. So if you think of your TV, you know your TV has that that settings. You can go into the settings menu and then you can set the brightness of your TV, etc. You can change the volume, etc. All of that stuff is actually firmware. If you go to the washing machine, you'll see that you can press buttons and you can actually program the washing machine like different functions and stuff. that is actually an operating system, but we call it firmware for the washing machine. Okay, stuff like your DVD player and stuff will actually have a firmware, etc. Even your new age fridges, it can, some have that nice screen that will tell you what the degrees are inside of the fridge, and how many times it was opened, and how many energy it has wasted, stuff like that. It's like very nifty stuff, but it's actually, you would think of, ah, it's just a function, but it actually needs something to do that functions, and that is firmware. So it's not as advanced as our Microsoft Windows and Android and stuff like that, but it's still just operating software, system software, but it's very low level. It's just doing like basics, and that is what firmware basically does.
Sir, so all devices have firmware.
Most probably all of the devices have firmware. If it's digital, it's doing something. Most probably there's gonna be some sort of firmware involved.
Yes, sir.
Okay. So next up is compilers versus interpreters. Okay, so a compiler versus an interpreter. So what this is when we are dealing with um, Delphi. You know, Delphi we use to write code to the computer, and Delphi will actually, when we click the play button, it basically takes all the code that we write, it translates it to a low level computer language. So it translates it to binary, like ones and zeros, so that the computer understands what we typed in normal English. Remember, our computer doesn't understand English, it understands ones and zeros. So whatever we write in Delphi, as soon as we click the play button, it will translate whatever we say to the computer, and then it will basically run it on the computer. Okay, so these platforms, what other languages we get? We get Delphi, we get Java, we get Python, C++, if you have heard of some of that programming languages. They can be divided into two different categories of how can I say it? Code writing software or coding languages. The first one is called, let me start with interpreter. I like interpreter. So if you think of an interpreter, if you think of a real life interpreter, let's say someone is watching the news, you'll see that there's like the person that's actually speaking, and then in the corner there on the left hand side, normally there's like someone that is using sign language so that deaf people can also watch the news. Do you agree with me? Have you ever seen that? It's like there's someone that's interpreting what the person is saying but in sign language. So once the person says a sentence, the interpreter will basically communicate the sentence. Then the person says the next sentence, the interpreter is gonna translate the next sentence. So that is basically what this interpreter software will do, is it will take all your code, but it's gonna go to the first line, translate it, tells it to the computer. Then it goes to line 2, translates it, tells it to the computer. Line 3, translates it, tells it to the computer. So it doesn't go, translates everything, and then tells it to the person at the same time. So just imagine if, the lady on the news says like for 10 minutes, she talks straight, and then the interpreter had to listen for 10 minutes, and now he suddenly has to remember everything and start translating it all at once. It's going to be disastrous if he doesn't have notes. So that's why it goes line by line. That's all you need to remember. It translates the code line by line and then tells it to the computer line by line. So like I said, it's going to take the first line, translate it, tell it to the computer. Next line, translate, tells it to the computer. That's what an interpreter does. Do you understand? Basically.
Yes, sir.
Okay.
Sir, can you just please repeat that?
Okay, interpreter translates line by line of your code and it basically executes it. So it's going to go to the first line of code, translates it into the language the computer understands, so ones and zeros, and then it will execute it. Then it goes to the second line of code, translates it, tells it to the computer. Then it goes to the third line of code, translates it, tells it to the computer. So if you have to define it, an interpreter goes and translates the code line by line. That's all you need to know. Whereas the next one over here, a compiler, and this is what Delphi actually does. Once you click the play button, a compiler goes, it translates all of the code, everything, from start to finish, it translates all the code to the computer's language, and then it runs. So the difference is, interpreter goes line by line, compiler translates all the code at once. Are you with me?
Yes.
Alright. Now the differences, the main differences between the two is as follow. Once you click the play button of an interpreter, it's gonna start immediately. Within an instant, it's gonna start, it's gonna run your application, because what it only needs to do, it only needs to take the first line, translate it, then goes to the second line, translate it. So it's gonna be very fast to open up. But once it is opened, it's gonna be very slow. Because remember, I said if you click the play button, it just needs to translate the first line. So it's gonna open up very quick. But now once you click on something, it's gonna need to go to the piece, translate it first, tells it to the computer, and then the instruction is gonna run. So an interpreter, it opens up quickly, but once it is opened, it is actually very slow. It's gonna run slow. Okay, because it needs to, in the moment, translate whatever you're trying to do to the computer. Whereas with a compiler, remember, a compiler takes all of your code, it translates it first before it even starts running. So the compiler needs to go, okay, translate line 1, translate line 2, 3, 4, until it reaches the end. Once it has translated everything, then the code will run. So a compiler is going to be much slower to open up, but once it is opened, it already translated everything. So once you click on a button, it already knows what you're trying to do. It just directly tells the computer. There's no need to retranslate because everything is already translated. So that's the two differences between the two. An interpreter is fast to open, but slow once it is open, whereas a compiler is slow to open because it has to translate everything before it can even open, but once it is open, it's much faster. Okay, are you guys with me? Yay, nay? Oh, oh, you guys still good?
Yes, sir.
Okay.
So I can't really hear you properly. Breaking.
Good. Okay, I'm just going to repeat once more. An interpreter translates the lines one by one, whereas a compiler translates all the code at once before it opens up. So the two differences between the two is an interpreter is quick to open, but once it is open, it actually is very slow, whereas the compiler is slow to open, but once it is open, it's much faster. Okay, then I'm just going to quickly go through this virtual machine one, and then just the last one, almost done, sorry. The virtual machine is basically all you need to know for now is what a virtual machine is. The word virtual means it does not really exist. Okay, it does not really exist. So when we are talking about virtual in IT, it is normally like software generated. Okay, so if you speak of virtual, it is something that is generated via software. So that is what virtual means in IT. So if you're talking about a virtual machine, it is a computer that is generated with software. So the computer actually doesn't exist, but the software will tell the computer, listen, you exist and you can use the computer on another computer. So to just give you a quick example um, of a virtual machine, I've got Windows that is my main operating system. Okay, I use Windows, but on Windows, I have this application. Ay, why is it so slow? I have this application that is called VirtualBox. Is it gonna open anytime soon? Okay, there we go. No, there we go. Okay, sorry. I don't know. My laptop needs a restart or something. It's terrible at the moment. So I have my main operating system Windows. Then on Windows, I have an application which is this VirtualBox that I have installed. And then on this VirtualBox, you can actually go and load other operating systems. So I can go ahead and load Mac operating system on here. I can load Linux. I can go and whatever I want to basically use, I can go and load into this virtual machine. So whenever I need to basically, like, let's say I'm an app developer and you need to create an application for people that are using Windows 7. You need to make an application for people that's using Windows 8, 10, 11, that people that's using Macs, etc. It would be silly for you as a developer to go buy a device that has all the operating systems. So that means you're going to sit at your house with like 10 computers just to each one have their own operating system on so that you can test your application. Whereas what this virtual machine will do is I can have one device, which is my Windows 10, and on it, I can actually go and load other operating systems. So once I've developed my app, I can just boot into my operating system. Let's say I want to test it on Mac. I open up my Mac virtual computer, virtual machine, and then I test my application. Then I go to my Windows 7, I boot into my Windows 7, and it's like a full computer. You can do everything you can do on your main computer, and I can test my application. So what it basically requires of me is I only need one operating system, which is going to be my main one, and then this virtual machines will allow me to basically just, I don't need another device. So the only thing it does is it will basically take your resources of your computer, so your CPU, your RAM, your storage, and it will basically take part of it to use for the virtual machine. So it will steal a piece of your RAM, steal a piece of your CPU, steal a piece of your storage, and then it will create like a virtual computer on your device. So it will tell, okay, I'm going to use this RAM, this storage, this CPU, that is my computer. And then the software, like the operating system, actually uses that parts of the hardware resources you have on your computer to act like it's a completely different computer. Okay, don't worry. Grade 11, I think term 3 or something, we're going to go into very much detail with virtual machines. For now, all you need to know, it is an operating system or it's a computer that is generated via software. That's all you need to know. Virtual machine is a computer that is generated via software. So it doesn't really exist. Are you with me?
Yes, sir.
Okay.
Yes, sir.
Alright, I would have showed you these ones, but these ones are very outdated. I haven't booted them up in a long time. I think one is actually corrupt. I played a click around with those. So, yeah, I broke it at the end. Then I'm just going to go to the last one over here. Number 4. multitasking, multi-threading, and multi-processing. Okay, I'm gonna start with the easiest one over here. It's the multi-processing. Alright, so on our computer, we have our CPU. Okay, and you know the CPU has got cores. Did you know that?
No, sir.
Okay, let me.
So Mr. Can you explain to us then?
Is it? Okay, so if I can quickly just show you this. I think you did. So,
You weren't paying attention, that's why.
oi, ouch.
What you doing? What you doing?
You weren't paying attention.
Okay, so this is our CPU, and if we turn it around, it's gonna look like this. This will be the bottom side of our CPU. So over here, you can see that there is like smaller diodes, etc., on our CPU. And normally, our CPU actually has, we call it cores, like CORES, cores. But what it is, okay, it is basically just small CPUs on a CPU. Okay, so if you talk about a quad core CPU, it means that a quad stands for four. It will have four individual CPU cores on that CPU. If you talk about a dual core, there will only be two CPU cores. Okay, if you talk about not quad core, octa core, octa stands for 8, there will be 8 cores. So what multiprocessing is it means that there is multiple cores that work together to do the processing. Okay, multiprocessing, multiple cores that work together to do the processing. Okay, so it actually needs to close Word first before you can actually load in Discord. Because there's only one thing, it can only do one thing. So if you had to open up Microsoft Word, and now you want to open up, let's say, Discord, it actually needs to close Word first before you can actually load in Discord. Because there's only one thing, it can only do one thing at a time. Can only process one thing at a time, but then they discovered multiple cores, so your information can actually be like Word can be processed by core 1, Discord can go to core 2, if I'm listening to Spotify at the back, it can go to core 3, so each thing can actually be processed all at once, but on different cores. And that is basically the point of multiprocessing. So if I want to ask you which component in the computer will be responsible for multiprocessing, it's the CPU. The CPU allows multiple processing. Are you with me?
Yes.
Okay. Then we're going to go to multitasking.
Yes, sir.
Multitasking,
Code.
that was multiprocessing. Okay, multitasking is the following. Okay, while I'm actually speaking to you, your brain is doing a few different things. Okay, number one, what is it doing? It's actually hearing my voice. Okay, number two, it's taking my voice and it's trying to make sense of it for you to understand it. What it's also doing is your eyes is looking at the screen. That's the third one. Number four, your brain is actually trying to whatever you are reading on the screen, it's also trying to translate it, but it seems like your brain is doing all of these things at once. Okay, you are basically doing everything while you're listening to me, you're also reading, you're also trying to understand what you're reading, trying to understand what I'm saying, when in fact, you are not actually doing everything at once. What your brain does is a few milliseconds, your brain is allowing my voice to go into the brain. Then for a few milliseconds it will try to understand what I'm saying. Few milliseconds it's actually going to read on the screen. Few milliseconds it will try to make sense what you are reading. And then that process keeps on repeating itself. So it will give me a bit of time on my voice, give a bit of time on understanding it, give a bit of time on whatever you are trying to read, or if you're looking at the ceiling. It's basically just allowing a few milliseconds per activity but it's not doing everything at once. It's impossible. It can't do everything at once. Okay, that's even when you are walking and talking, your brain actually swaps between the ability to walk and talk, walk, talk, walk, talk. So it will basically swap between these two activities, and it does it so quick, it seems like it's doing it all at once. And that is multitasking in general life, if you're just speaking about a human. But in IT, what the word multitasking is, it's exactly the same thing, just based on computers. So what multitasking will be is, as you can see here on my computer, I've got Discord open while I'm speaking to you. I've got Microsoft Word open. Even my Google Chrome is open here in the background. So at the moment, it looks like, yes, my computer is very smart. It's doing all of this stuff at once. I can type while I'm speaking to you, while Word is open. It looks fantastic. It's doing it at once, but it's not actually. So what multitasking is it's the CPU will split its processing time between all the open applications I have. So it will allocate a few milliseconds to Word, it will allocate a few milliseconds, and remember, milliseconds is very fast. It will allocate a few milliseconds to Discord, a few milliseconds to the internet, a few milliseconds to Chrome, and then it's going to start again at the beginning. So it's going to go Word, Discord, Internet, Word, Discord, Internet, and it keeps on repeating itself. And it's so fast that it looks like the computer is doing everything at once. So if you have to define multitasking, it is when the CPU splits its processing time between all the open applications so fast that it looks like it's doing it all at once. Are you with me? I hope that makes sense.
Sir, I just want to make sure if you're recording this because
Yes.
apparently in person.
Ah, hectic, shame. Yeah, I am actually recording it.
Okay, thank you.
Perfect. I'll upload it. So a few people dropped. Is that what I heard? Oh yeah. Hectic.
It's just Roddy and I.
Ah, shame. Okay, so I'm just gonna finish up with the last one. So that was multitasking. So what multi-threading is when actually one application breaks itself up into multiple different pieces that can get processed individually. Okay, so if you're thinking about, let's say, Microsoft Word, I've got it here in front of me. When you are typing on Microsoft Word, it does a few different things. Number one, it actually takes in whatever you are typing. Number two, it will take the characters you type and put it on the screen. Number three, while you are typing, it will actually do a spell check. And number four, let's say you've got autosave on, while you're typing, it's automatically saving the document for you. So your one application breaks itself up into smaller parts, which we call threads, so that it can process it individually. So your typing will be maybe in one core, your spell check will be in another core, your autosave will be in another core, and it basically will swap between all of these stuff, basically just breaking itself up. So it's going to do everything individually, process it individually, so it just makes your whole computer faster. So that's all you need to know. So with multitasking and multi-threading, if I ask you what is the difference, or what, sorry, not what's the difference, which component is responsible for these two, it's going to be your operating system. So your operating system is in charge of, remember, it manages your processing. So it's actually going to allow multitasking to take place, multi-threading to take place. Okay, are you with me?
Yes.
Okay, so that is all the theory. So for the practical, you just need to make sure, I think Mr. Crunier said he did everything. It is, you need to know with string handling, that's going to be question 1, you need to know the length function, the copy function, uppercase and lowercase functions, the position. So if you need to find the position of a hashtag or a position of the a space, etc., you need to know the delete function. And then with arrays, you need...
Back, so we have load shedding.
Ah, shame. Okay. Yeah, I have it recorded, so I'm gonna try to upload it as soon as possible. Okay. With arrays for the question two, number one is you need to know actually how to create an array. So that's, yeah, very easy. Just know how to create an array. Number two, you need to know how to create random numbers. And obviously, maybe you're gonna need to store these random numbers in the array slots. Next up, you need to know how to search through an array. So if I tell you, ask the user for a number and search through the array, and you need to give the position of where is that number in the array, you need to be able to search through an array. Next up is you need to be able to sort the array, either low to high or high to low. You need to be able to change. So if I say, okay, change the number to from let's say 5 to 10, you need to be able to go through the array, find the one you need to change, and then update the value. And then getting the sum, um, maybe calculating all the numbers, add them together, or find the highest one in the array or the lowest one, or even calculating the average. Okay, so the time is, I'm actually 10 minutes past. So for the practical, Mr. Krunier said, if you have any questions, please just feel free to ask him. But yeah, that is all. So the theory is the main focus for this lesson. Practical, again, it is gonna be online. So I must just ask him. I don't know if he has confirmed with you guys yet. I'll just ask him to confirm when it is. But it's gonna be in the evening. So normal class time. You're just gonna get an hour. You're gonna log in on Discord. You're gonna go. He's maybe gonna give you a few instructions. Then you're gonna go into Google Classroom, download the question paper, do the answers. So it is gonna be open book. But remember, open book is not easier. Don't fool yourself. Don't think you're gonna get here and then we'll just see, rely on all the notes. Okay, because that takes time. And at the end, you're gonna do like half of the paper because the rest of the time was spent on, how do I do this? How do I do this? How do I do this? Etc. So it's gonna be online. It is gonna be open book, but it still need to study. Open book is harder, always. Okay, but you just need to know these few things for the practical. And then again, if you have any questions, just message Mr. Krinia. Okay, that,
Sir,
yes,
for the maximum and the minimum value, we have to like find like a number in the array, and then
yeah,
we have to. Okay.
yes, that's the lowest number or the highest number, etc.
Okay. Thank you, sir.
Okay, cool.